Hello, everybody. Mr. Rubo here, and today we are talking topic 213, which we have split up in lots of days. So there'll be quite a few videos for this, but we're going to start with exponential and log equations and inequalities. So yeah, you've worked with exponentials and log functions, and using properties to simplify expressions and write equivalent expression representations. So we're now going to start solving them. So we looked at the inverse functions and finding the inverse of a given function, including that exponential and logs are the form y equals b to the x and y equals log base b of x. So finding the inverses of log and exponential functions, well, it's just like everything else. You switch. Oh, my stylus decided not to write there. You switch the roles of x and y in the equation. You then use inverse operations to solve for y in the inverse relation. In exponentials and logarithmics, you change between the two forms, and then you write the final function using inverse notation. Which, just as a reminder, inverse notation is when we say f inverse of x, or whatever the function is, right? All right, so here is our example. Wants us to find the inverse of this exponential. So just like we would do for any other function, doesn't matter that it's exponential or not. First thing we're going to do is switch x and y. So I'm going to say x equals 2 times 2, y plus 4 minus 15. Okay. And now, though, we don't like having y in the equation. We always like having it y in terms of x. So let's start solving. So I'm going to add 15. Okay. Oh, don't like that 3 in the front, so I'm going to divide by 3. And I'm going to leave that alone. I'm actually going to leave it as that lovely fraction there. Oops, forgot the 1. And now I have an exponential. Just an exponential equals some expression, right? So this, though, is where logs come into play, because we want to get rid of the exponential. The way we do that is change it to a log. So here's my base. So it's going to be log base b of the other side of the equation equals the power. And now you'll notice, hey, y is almost by itself. All I have to do is subtract 4. And the 4 that is being subtracted just stays on the outside. And we would have y equals, but I'm going to go ahead and write it as f inverse of x. And usually we write it on the left side, but it doesn't really matter. Okay. So yeah, there is how we would solve that one. That's how we'd find the inverse. Again, switch the x and y, start solving it for y. But if you get to a point where you're stuck with an exponential, switch it to a log. All right. So now let's go the other way. Here we want to find the inverse, but we have a log in here. So again, the work is exactly the same for anything else. When we want to find the inverse, you switch x and y. Oops. Log base 5 of y minus 4 plus 6. And now we're going to start, we want to isolate y, so let's start getting rid of some stuff. So I'm going to subtract 6 first. Divide by -3. And just like before, I'm going to leave that fraction alone. Now, to change this to get y by itself, we have to get rid of the log. To get rid of this log, we switch it to an exponential. So it's going to be base 5. And now the other side is going to become our power. And then what was inside the log is going to be on the other side of the equation. And then just like before, I got a -4. So my last step is to add that over to the other side. So I would have this x minus 6 over -3 plus 4. And then it would be g inverse this time because we dealt with a g, right? It was g of x. So yeah, there you go. And that is writing the inverse of an exponential and writing the inverse of a log. So yeah, thanks for watching. Have a good day.